Greetings, I'm Squared here. Today we're going to talk about central angles. But the first thing I want to do is talk to you about the difference between measure and length. So if I wanted to find all the way around the circle in terms of the measure, I would be talking about degrees. So around the circle is 360 degrees. That's different than the length around the circle. To find the length, I would use circumference. So let's say that I had a radius of 4. So to find the circumference, I'd say circumference equals diameter times pi. Well, the diameter when the radius is 4 is 8. So if this was centimeters, then I would know that my circumference was 8 pi centimeters, and pi is roughly 3. That's an estimate. So about 24 centimeters all the way around the circle. But if I'm talking about the measure, and I think measure should have an S in it. If I'm talking about the measure, then I am talking about 360 degrees. So today, one of our main things that we're learning is that the central angle, the measure of the central angle, so in this case it's 90 because we have a little box there, is equal to its intercepted arc. So that this measure would be 90. But that's not the length of it, because if I wanted to find the length of that, I would use my n over 360 times 2 pi r. That's what I would do if I wanted to find the length of AB. So the measure of arc AB is 90 degrees. The length of arc AB is, I'd have a 90 over 360, which that reduces to 1/4. So I have that 4 cancels with that 4. So that 4, right? So I would have 2 pi centimeters, which would be the length of AB, but the measure of AB would be 90. So I just want you to understand the difference between measure and length as we go into this, because sometimes they're going to ask you for the measure, and it's not this formula. You're just going to look at the degrees. So again, remember, our main goal is to remember that the central angle is equal to its intercepted arc. So if I'm trying to find arc YZ, then I look at this angle that's intercepted, this central angle, and I know that it's the same. So I know that the measure of arc YZ is 60 degrees. If I want to find the measure of arc YX or XY, I'm going to notice that there's a diameter right here, and that diameter splits the circle into 2 semicircles, which means this is 180 degrees and this is 180 degrees. So if I know that these two are 60 and 50, that I can find this one by taking 180 and subtracting those two from it. And then I would know that that's 70. Once I know that this is 70, I know that my arc is also 70. And I know it's not drawn to scale because this looks smaller than those two. That's sometimes how it works. Well, how could I find these two? Well, I can find this one by noticing vertical angles. This is 60 degrees. And I can find this angle by noticing the semicircle minus 160. So 180 minus 160 is going to be 120. So that's how I can find that. And then if I was asked to find the measure of arc ZWX, then I would say, okay, that's from here all the way to here. So that's either 120 plus 60 plus 50, or I could take 360 and subtract these two. So 120 plus 60 is 180. 180 plus 50. 180 plus 50 is how I would do that. So I would get 230 degrees. Okay, so last thing for today, we're going to look at this one. Remember, a central angle is equal to its intercepted arc, but then you also have to remember all the other things we've learned this year. So first of all, I'm going to use this. This central angle is equal to that arc, so I would say 60. I would also notice that that's a diameter, which means this is a semicircle. So if I wanted to find arc DB, I would subtract 60 from 180, and I would get 120. Well, then that tells me what this angle is. I could have also seen that these are supplementary angles. So I also need to find the measure of angle DBA and the measure of angle ADB. So I want to find these two angles. So when you look at a problem and you're kind of confused, like how are you going to do that, always go back to things that you know. So I know that all the angles of a triangle add up to 180. Hopefully you noticed that triangle there. I also know that in a circle, all radii are the same. Well, once I've marked those, then I realize what kind of triangle this is. That's an isosceles triangle. And an isosceles triangle, the base angles are congruent. So that means these two angles are equal because the sides were equal. So now I know that I need 60 more to get the 180 from this triangle. And I know that both angles have to be the same. So if I divide by 2, I can find the measure of each of those angles. So each of those angles would be 30 degrees. So that's a little bit about central angles and intercepted arcs. And good luck with your homework. M squared, signing out.